Okay, so the purpose in this video is to solve this projectile motion. This has a bit of a SUVAT touch to it. This projectile motion question, as most do, and we hope to go through this question. So, show the path. What we can see here in the picture is that we are looking at a golf ball path struck at point F and landing on the fairway, or off the fairway, on the green. I wish I could do that. And we're looking at the fact that the effect of air resistance is negligible. So, we're told that the ball leaves the club at 17 meters per second, angle of 60 degrees to the horizontal, at time 0. Show that the speed of the ball at the highest point h of the trajectory is between 8 and 9 meters per second. Okay, so we're going to just discard the paper real quick, and then we're going to come back to the question. Okay, so looking at the question, what we can see here is that we have a situation where we have a main component of the velocity, 17 meters per second, going in that direction there. Now, as we know about vectors, this will be made up of a horizontal and a vertical vector. So let's just draw those in. We know that this angle here is 60 degrees, and we then know that that angle is 30, but that's kind of irrelevant for what we're looking at to do today. So, we need to divide this up, and we're actually asked to show that at the top of the height of this trajectory, that the ball's velocity is approximately between 8 to 9 meters per second. Okay, so we need to look at this situation very carefully. Okay, let's look at this vertical component here. We're going to calculate this vertical component in a second, but let's think about it qualitatively at the moment. Okay, so imagine if you would throw a ball straight up in the air. Eventually, what velocity would it have at the top? Well, it would have 0 because it's not going anywhere. For an instantaneous moment, it would have 0 velocity because it would slow down with a deceleration exactly as gravity, 9.81 meters per second. So once it reaches the top, it has a vertical velocity of 0 meters per second. So that actually tells us quite nicely that it doesn't really matter what's happening here, because we know that the effect of the vertical velocity is going to have absolutely no impact upon what the velocity is at this point. So we can forget about this. However, what we're looking at here is, well, we need to realize that there is a horizontal component to this velocity as well. So let's work it out. So 17 meters per second is our hypotenuse. I'll label that as h. The horizontal component we will label as the adjacent, which is there. So what we can do here is we can do a quick little sum. So we're going to use trigonometry again. Cos theta equals the adjacent over the hypotenuse. We want to find out the adjacent here. So the adjacent, with a quick bit of algebra, is just quite simply cos theta times by the hypotenuse. So when we plumb these numbers in, cos 60 times by 17, and when we put that into our calculator, we get 8.5 meters per second. Okay, so let's look at this whole situation now. We know that at the top of the hit, the vertical velocity will be 0. We know that the horizontal velocity is not decelerating or accelerating in any way. Why do we know this? Well, it's because the air resistance is negligible. The only thing that's going to act on something moving in this direction on its own, no vertical displacement, would be air resistance. But since air resistance is completely negligible, we can ignore any deceleration that would occur in the horizontal direction. So we're saying that at this point, it's 8.5 meters per second. The vertical velocity at this point is the horizontal velocity at this point is 8.5. This point, this point, this point, this point, all the way along this trajectory, its horizontal velocity stays exactly the same because we have no or negligible air resistance. So we could quite nicely prove there that because that is completely irrelevant, we are quite nicely shown that 8.5 meters per second is between our 8 to 9. So we have shown that, and we will have gotten our answer correct.